And we're back. Hi, everybody. Welcome to the Unreal Engine live stream. I'm your host, Alexander Pascal, but words tripped over them immediately. But joining me today is Ryan Gerleve, and we're going to be talking about replication in general and a lot of Q&A around that. So let's hop right into it. We have a project here that you wanted to talk about how it all works. Clint, main menu.
All right, so to get started, I thought I'd just show off, this is just the first-person blueprint template project that you can open up from the Unreal Engine. Mm-hmm. And if any of you have played with it before and tried to play it in multiplayer, you may have immediately noticed some issues where it doesn't quite work as you might expect or as you might want. So I thought I'd go through pretty quickly and kind of show you guys how you would fix those problems in this first-person template, and that'll kind of be kind of a nice overview of some of the replication features in UE4. It might be a little bit basic for those of you who with some more experience, but for those of you new to the engine, hopefully this will be very helpful. And then once I'm done with this, we can probably just start taking your guys' questions.
Cool. So. And just so everyone at home knows, and if you're trying to follow along with us, this is started with a first-person template, and then we went to Add New. If you're not familiar with that feature, if you click on the Add New button, Add Features and Content Packs, and then we just added the third person right into it. And so that's kind of what we did as pre-prep. So I'm not going to provide you guys with the project for this one like I sometimes do. This one you guys can just slap together pretty easy. Just want to clarify that. Sorry, Ryan, you go right ahead.
No problem. And you guys will see why we want to use the third-person content very shortly. So first of all, I'll just show you, unmodified with a two-player Pi session, so you can kind of see. Let me do that in a new editor window. So you can kind of see some of the issues I was referring to before. I'll move these around so you can see both players simultaneously.
Mm-hmm. You can kind of see the floating gun the other person is.
Yeah, exactly. So this is the server instance. You can see he's moving around, but the client only sees this floating gun, and the client is the same. So another thing you might notice is when the client fires his gun, the server doesn't see any projectiles. That's not quite right. And then even if the server fires his gun, the client doesn't see any projectiles either. So that's a problem. And then these boxes are just static meshes with physics. I can kind of shoot them and bounce them around a little bit, right? But I don't see these boxes. Their physics movement isn't being replicated here. So I can see the boxes move, on my own instance, but for the other players, nothing happens at all. So I'm gonna show you guys how to fix these things. We're gonna add the third-person mannequin model to the remote players, so you can actually kind of see a character running around. It'll look a little bit more like, a proper multiplayer game. So let's get that character in there. We'll just jump into the first-person character.
Mm-hmm. The blueprint. First-person BP.
Blueprints, first-person character. There we go.
Yep.
And then, so this is just the default one. I haven't changed this at all yet. This is exactly what comes out of a new template project. So we have a couple of meshes here, right? We have the arms, and we have the gun, and we have the VR gun. So I'm just going to add a new skeletal mesh here. Not under VR gun. I will call this third person spell. And then just move it out. All right, so we'll just grab the third person.
Now you want to hit the drop down over there.
Right.
Which is none. Mm-hmm.
Grab the third-person mannequin here. Use the anim blueprint just for now. I'm not gonna like modify any of the animations or anything. Of course, if this was your own game, you would want to update the animations so that they match the gun model and all that stuff. Let's just move him down a little bit. All right, so we now have the model there. Let's see what that looks like. Now, of course,
He's just standing right inside the camera.
he's standing right inside the camera, right? So we want to not show the mesh, obviously, for the local player, but we want to show it for any, remote players who are in your game session. So an easy way to do that, I'll just go over to the event graph here, and in begin play, I'll make some room here. We basically just want to hide that mesh if we are a local controller. Or if our pawn is locally controlled, sorry. So this is locally controlled function. Will return true if you're the local pawn, or false if this is the pawn for a remote player who's in your game. So if we are locally controlled, we want to set this to be hidden.
Mm-hmm. Yeah, we don't want to be seeing our own mesh.
And then we'll just carry on and do the rest of the setup that this was switching for VR mode. I'm not going to change any of that for right now. So let's see what that looks like. Oh, I must have gotten something wrong here. If we're locally controlled, actually have to check the hidden box. That would help.
If it says true, then it is true.
There we go.
Yeah.
Okay, so as you can see, the mesh, I don't see my own mesh, but I see the mesh for the other players here.
Mm-hmm.
The gun is kind of in a weird place, sticking in the middle of his chest there. So we could fix that real quick. Not necessarily related to replication, but I'll show you anyway. If we just jump into the skeleton
Mm-hmm.
here, we can just add a socket to one of his hands. Probably just add one right here. Call it the gun socket. And then
you can just get a preview of it.
that's always useful.
Yep.
Grab the gun mesh right there.
Yep.
And then
Yeah, just make it fit a little bit better on the hand. Or not at all. It doesn't matter. You can hold it backwards. It's just for visuals. A couple people pointed out in chat that in addition to the hidden, you could also do only owner see or owner no see for hiding mesh options, for like visibility options as well. If you do
yes,
visible.
that is.
Is there any difference there, or is it just you just did one and you have to just pick one?
I mean, in this case, we probably just pick one.
Mhm.
I guess the advantage to using those options is that the engine kind of handles the ownership logic, whereas with the way I did it, I checked the locally controlled function. So it's not really a big deal either way. It's probably slightly easier to just use those options, which I didn't think of in the moment. But thank you for pointing that out, chat.
It's all good. They just they're always curious about alternative ways to do anything.
Of course.
Trying to make it look really fancy.
Trying to.
Select off of it and select back on it. Yeah, sometimes it jumps to the origin selection. There you go.
Like something like that.
Yeah, that's about right. And he's got a gun in his hand.
Yeah. Like I said, obviously you'd want to, make this Oh, of course I have to actually attach the gun to the socket. So some more room here. Take the gun. I think it's this one.
What's this one you're doing? Oh, you're just attaching the attaching
yeah,
a new
so
component as you spawn it in, because we were just
yeah, so
visualizing before, it wasn't actually attached.
Right, that's correct. So I added the socket, but now we actually have to attach the gun mesh to the socket on the actual instance of the pawn when it spawns. So that's what this is doing. Although we only want to do this for remote players, because those are the players who we're going to see the third-person mesh for. So if we are not locally controlled, attach. And then the parent is the third-person mesh here. And let's see. All right, and you can see the gun is attached to their hand now.
Yeah.
So not all strictly related to replication, but I just wanted to get that out of the way. Now we can start looking at you know, why these projectiles aren't replicating and why these boxes aren't moving around. So you know, a lot of things in the engine do kind of replicate by default. A lot of the classes that come with the engine, like the character, for example, which these pawns are characters. They use the character movement component, which handles character movement replication kind of automatically under the hood for you, which is why I can see these characters running around without you know having to kind of do any extra additional work. So let's get those boxes to work, because that's pretty simple, a pretty simple thing to fix. So let's just take a look at like this box right here.
Yeah, we were just kind of knocking it around earlier, and it wasn't doing us much good.
Look at the details here. So this is just a static mesh, I believe.
Yeah, it should just be with physics turned on and some collision set up.
Yeah. So I believe that there's a static mesh replication flag in here that's probably just not turned on. Yeah, okay, so static meshes have this flag here, static mesh replicate movement, and you can see it is off right now. If we turn it on, then the engine will automatically replicate movement changes for these meshes that happen on the server to all the clients that are connected.
It's just a checkbox.
So we actually want to do this for all of these cubes, so I'm going to do that real quick. Just select them all, enable for all of them, save it, and now we can give that a try. So let's face the same cube here. So
you can kind of see it there.
So watch the cube on the left-hand side, because I'm going to shoot it with the one on the right.
Uh-oh.
And it's not
replicating.
It's not replicating. So the problem here is, notice the one I'm shooting from the client's perspective, right? The client is on the right. And I mentioned how that flag means that the server will replicate. Basically, everything by default is server authoritative. So the server has the ultimate say on you know, the final state of all actors' properties and positions and all of that. So when the client moves this mesh, the server doesn't know about it, so it doesn't know, you know, to replicate it to anybody else. So let's try the reverse. I'll switch over to this cube that's behind us here.
Yep.
Only I'm going to shoot it with the server this time.
And
you'll
now
see
it replicates properly.
that it is actually replicating properly. So this kind of leads to another issue with multiplayer in this template, is that the projectiles that we're firing, obviously on the server, they're colliding with these boxes, so you can see them interact there. But the projectiles aren't being replicated either, right? So we noticed before that when either the server or the client fires the projectile, it
You're
doesn't
not
show
seeing
up
them at all. Yeah.
on the other screen. So when the client fires a projectile, the server again has no idea that that projectile exists. So it has no way to simulate the collision between the projectile and the boxes, for example.
Mm-hmm.
So what we need to do here is basically when the client fires his weapon, we need to send a replicated event to the server to let him know that he's firing his gun, and let the server respond to that and spawn the projectile, which will be an actor that will make replicated. So the server will spawn it and then replicate it back to all of the clients. But since the server spawned it, he'll be the authority over that object, and he'll be able to run the physics simulation where it will collide with the boxes and everything, and then that causes the server to run the simulation on the box, and then he can also replicate changes to the box to all the clients.
Yeah.
So that might have been a lot to take in, but we'll kind of go through it one step at a time here. The first thing to do will be to make those projectiles replicated. That should be pretty straightforward as well. So let's grab the asset for that. First person. I think it's a blueprint here. Yeah, so we have this first person projectile object, and it has some, so it has its hit event where it applies the impulse to the object that it collided with, but I believe it is not flagged for replication.
Yep.
So here in the details panel, all actors have kind of these default replication settings, and this flag right here, replicates, is the key. This basically controls whether it replicates or not. So all we have to do actually in this case is check this to true, and this means that for objects of this type, actors of this type that are spawned on the server will automatically replicate them to all the clients. So if we run this, we should be able to, the client should now be able to see the server's projectiles, and you can kind of see them off to the side there. The client on the right. And again, the animations don't line up because we didn't make any animations for this specifically, but you can see the projectiles there are getting spawned and interacting with the boxes. However, we still have the problem where when the client fires,
we're still not seeing the client.
We're still not seeing any projectiles on the server. So this will happen because in the character's blueprint, where we handle the fire input, which is down here. So we're just handling this input locally on the client. So when you press the fire action, we play this montage. We spawn the actor. This spawns the actual projectile, and we play the sound. So this spawn will occur on the client. Again, the server doesn't know about it. So generally, for anything like this that is going to be important to gameplay, you do want to spawn those things on the server. It's okay to spawn actors that are just kind of cosmetic and don't really impact gameplay on the client if it's just, a simple like particle effect or something that's just kind of there to look good.
It's just there aesthetically.
Yeah, then that's perfectly fine to spawn on the client, and it's actually generally better to do that because you will end up saving bandwidth because it won't have to replicate necessarily. But for this case, for this projectile, we want to actually send an RPC to the server to let the server know to spawn the projectile. So I'll go ahead and add a custom event to do that. And then we kind of have a convention. You're free to follow this or not, but you'll notice it in our code and our examples. We generally, for replicated functions or events that run on the server, we prefix the name with server. And for client events, we prefix the name with client. So we're going to make this one run on server because that's exactly what we want. So when a client actor who is owned by the player controller on that client calls this event, the engine will automatically send it over the network onto the server, and the server will execute this event.
Huh. We actually have a question about why are events replicating and not functions. Let's see here. Raildex was asking, why are only events replicatable? Why not functions? We need to create an event just to call a function that should to get replicated. Do you know why that is?
I probably don't have a great answer for that. Events are a little more like kind of fire and forget entities, right? Like you can run an event and it doesn't return a value. Returning a value across an RPC is kind of tricky. I mean, you can always send another RPC back to the client when it's done, but to handle like a replicated function that returns a value would be a little more tricky. And I mean, it's just the way things were architected. I'm sorry, I don't really have a better answer than that.
I think that at least gets them in the right direction. One person had responded in chat that it might also have to do with you don't want to have replicated returns and replicating the return value of the function, I guess. But
yeah, I mean that's kind of what I mentioned. You can kind of, like I said, you can kind of work around that, but you would just have to kind of chain two replicated events together.
So you Shirley just had a sneezing fit and it was adorable. Sorry, everybody.
Yeah, so you can, if you do need a return value, you can kind of fake it by having a server replicated event, and then that in turn during its execution, when it's done, runs a client replicated event with a return value as the parameter, and then the client will get the return value, at some point in the future after it all goes through the system. Okay, so to fix this, we need to spawn the actor from the server event, and we don't want to spawn it on the client because the server is going to be handling all that. However, we will still let the client play the montage and play the sound because these events are not don't have like built-in replication, so we still need to execute these both on the client and on the server. So I'm going to reorganize this a little bit. So the way to tell whether we're on the client or the server, the most reliable way is to use this has authority node, which I'm about to bring in here. So as I mentioned, the server is generally authoritative on all of the actors. So if has authority returns true, then that essentially means you're running on the server. If it returns false, it essentially means you're running on the client. However, the gotcha here, though, is like, for example, if we did continue to spawn the projectile on the client, since it wouldn't be replicated and it would just be spawned on the client, that client would have authority over that actor. But for things that are replicated and spawned on the server, you can use has authority to determine whether you're on the server or not. So if we are the server, we want to, no, sorry. If we are not the server, we want to run the montage and play the sound. I'll unhook this. I'll just move that out of the way. This might get a little messy.
It's spaghetti. But yeah, you can see that it's just when it's false, montage play directly to sound.
Yeah, and I'll clean this up a little bit. Let's get ourselves a little more room here. So when we press fire, the first thing we want to do is check whether we're the authority or not. If we're not, move some of this stuff down as well. Is this actually used for anything? Yeah. So we want to do this if not going to be testing the touch input right now, but we would want to do the same thing in that case.
Mm-hmm.
Sorry, bear with me while I get this stuff all organized here.
Oh yeah, I'm sure they'll feel a lot better if it actually, starts aligning.
So we're still the client here. We played the montage. We played the sound. Now we need to actually execute the server event. So this will actually call the RPC, and I'll use the term RPC and replicated event kind of interchangeably. Replicated event is kind of the name for the blueprint. You can make a replicated event in blueprints, but for C++ code, we generally refer to replicated functions as RPCs. It stands for remote procedure call. So if you hear me use those words interchangeably, that's why. And
I see.
They are essentially the same thing, just one's a blueprint event and one is a C++ function. Okay, so what does this node connect to? A branch that is unused. I'll just delete that. So nothing was connected to that node, so I'm just going to get out of the way. Okay, and then we probably want the server. So the server will spawn the projectile, and then we'll also want him to run
the montage
and the animation. But let's not call this here because we don't want the server to call that again.
That'd create an infinite loop.
Exactly.
Which would be bad.
So we'll hook that up there. Okay.
Is that going to cause it to play the montage twice? If that's... Or... No, maybe I'm just wrong. It was just starting to look like it's looping on itself a bit.
Well, this will only get through here if this branch is false.
Mm-hmm.
So if we're a client,
yeah,
we'll run through here. We'll run this, and sorry, I see. So we actually want to, yeah, I think I had it backwards. So if we are the server and we fire, we want to
yeah,
actually
because if it goes through that, then it goes up there, right? Like it triggers that event. So then it'll go through and play the montage once, and then once it's done playing, it'll play through the montage again. Just trying to figure it out. That's why.
Actually.
All right. That makes some sense then.
Sorry, I think I can actually simplify this. Sorry, doing this on the fly, so they're going to be.
It's all right. Live
rough spots. I think we actually just want to call this directly. So this will actually just run, if we call this, whether we're a client or the server, this works because if you're a client, it will just call this function on the server.
Mm-hmm.
And if you're a server, it will just execute this event immediately locally on the server, which is exactly what we want in this case.
All right.
But if we are a client, we also need to play the montage and play the sound. Oops.
It's looking a lot more clean now.
Getting there.
Yep. Yep.
Go. So this is, I mean, just move all that back. It'll get a little messy. Okay, I'll just leave it there for now.
Yeah. You just have to have that one reach back. It's all over the place.
Right. So okay, I think this is what we want now. So on a Fire input,
Mm-hmm.
we call the RPC. So if we're a server, it will just run and execute this event immediately, spawn the projectile, play the animation, and play the sound. If we are a client, it will send the RPC to the server, which will then execute those events that we just went through when it receives it. And then we also want to run the montage and the sound locally on the client, because those aren't, like I mentioned before, they're not replicated by default. And we still want those things to happen, on both sides. So let's give this just a shot and see if I got this right. Okay, so this is the server. The server worked before, so we kind of expect that to work. But
how's the client looking?
If we check out the client,
Oop.
now you can see the client is firing his projectiles, and the server
A little more to the left, because he's looking to the left there. See those three over there? That's the one. Yeah.
Okay, so we have the projectile replicating now. And
yeah,
the client can shoot these boxes. That was the other thing that wasn't working before.
Yep.
So the client is, messing with this stuff, but the server is actually, running the physics simulation and then replicating the results back down to the client.
It's kind of a tricky thing that it's actually doing there, isn't it? It's kind of like a stone skipping how it works. Yep, double montage play on server, looks like. Yeah.
I guess that montage was actually for that's for your first person model with your hands in your gun. So we actually don't even need to run that for remote players.
Exactly. And can you add a second, they're asking, Fresh Lemonade is asking, can you add a second client and check that replication works between clients?
We can absolutely do that. That is
Sweet.
an excellent idea.
Yeah, that'd be really nice, because I know that's what this all kind of comes down to, is who can see what.
Right. All right, so we'll set number of players to 3. I can also check this with the dedicated server. All right, so our third player is on the other screen. Let me get these guys all set up here. Make enough room. Thought I had the arrow. So, all right, so client is on the upper right and on the bottom. So we'll see, you can see I'm a client, I'm firing my weapon, and the client on the bottom can also see my projectiles, and you can see the static meshes moving around. And then we'll just go through everybody, make sure it's all good. This client is working as well. Clients and server can see him. And then just to be sure, if any of these are going to work, it's usually going to be the server, but it's always good to check it. So yeah, I think we're good. Let's try. So I didn't test this beforehand, I'll warn you, but we'll try with the dedicated server as well.
Yeah.
That should also work.
Cool. I'm going to answer a really quick question in chat about this. Majaz, I'm sorry if I got your name wrong there, was asking, he's never done games programming before, but he asked, how long would it take us to set this up? A week, a month, or more? No, we just did this live. So if you're just joining us, this is live. We kind of just made this earlier, and we talked about at the very beginning how we combined some stuff up, and then we did everything else in front of you. So no trickery here or anything weird. It's just the templates from UE4. See, cool.
So yeah, so this is with the dedicated server. There is an extra player here. I think that's just because there's a character actor that had been placed in the map. So it'll just spawn by default, and then when the clients connect, it spawns the ones that I'm actually controlling from these instances. So that's why there's that extra character there. But as you can see, when we run with the dedicated server, both of these windows are clients, and they can both fire, see each other, and see these boxes move around. So, so that's a very simple replication setup for the first-person template from the Unreal Engine. You guys can grab it and play around with it if you like. I would like to just get these changes into the default template, so hopefully we can get that done sometime soon. It's relatively straightforward, all things considered. So yeah, if you guys have any other questions, or we can go to some of the questions from the forums, or...
Yeah, why don't we just jump on into those questions from the forums first? It seems like we have quite a few. And if we can't get to your questions here, I see there's like a ton popping into chat, and I've been grabbing them as fast as I can. But if we can't get to them, then we'll try to throw in some stuff for for the forums. Like, we'll answer them later on forums.unrealengine.com. But yeah, so let's see here. The first question that we have... matchmaking in Paragon. How can you talk a bit about matchmaking, how matchmaking's done, and anything you know about Paragon's matchmaking? And then, yeah, it looks like you have some notes on it too. So yeah, how does that work?
Yeah, that's an excellent question. So matchmaking can be a very complicated topic. So generally for Unreal games, what we do is we use our online subsystems, which are now plugins. We have some that come with the engine by default for Steam, for consoles, etc. So we generally, in those online subsystem modules, there is a session interface there are some Blueprint nodes that hook into that. Most of it is in C++. Like most of our internal projects, we use the C++ interface for this. And like, for example, if you want to use the Steam online subsystem, the session interface hooks into the Steam lobby system. So you can go through our API, and it will, if you're making a Steam game, for example, it'll create Steam lobbies for you and let other players find them if you use, the find options in there. For Paragon specifically, we use our own online subsystem module that kind of communicates with our own backend services for matchmaking. So those are unfortunately not, provided with the engine to you guys. but we still go through the same exact API, with iOnline session interface, find sessions, create sessions. All of that matchmaking is based on sessions, and of course our own, like I mentioned, our own backend services does a lot of the heavy lifting too of, matching players into groups and stuff like that.
Mm-hmm. Mm-hmm. It's not something that we would want to do as a single sit-down live stream. It would be a series of like a series of live streams where we'd have to chunk up each individual part of how a matchmaking system works, and it would take quite a while. But I think that's a great high-level overview of how those systems work. And cool. Do any of the BP movement nodes auto-replicate by default, such as teleport?
No, I don't believe they do. Most of the automatic or like default replication comes from the character movement component. I don't believe the teleport node, for example, does auto replicate. But it wouldn't be too hard to work around this yourself. You could write your own replicated event and send that across and update your positions in the implementation of that event.
Cool. During prototyping, is there a way to replicate everything on LAN by default?
No, not really. Generally, replication will work how you have it set up by the kind of the flags that I went through, whether actors replicate or whether static meshes replicate. I mean, those will either replicate or not based on those options, and there's not really a way to override that based on whether you're running on a LAN or not.
All right. Let's see here. Quite a few people are curious about the character movement component. And is it possible that in the future, character movement component might be divided up into smaller chunks to make it not only easier to customize, but also easier to adapt for more movement styles? And I think we had a few other questions just about the movement component in general and how it functions in replication. Can you talk on that one a bit?
Right. I can maybe a little bit. So I wouldn't consider myself an expert exactly on the character movement component.
Right.
Some other programmers have had spent more time working on that stuff. I will say I'm not aware of any plans to answer that first question specifically. I'm not aware of any plans to divide it up into smaller chunks anytime soon, although I can definitely see how that might be valuable.
All right. Let's see. Could we at some point have an updated content example which contains C++ code for matchmaking beacons and game and party sessions? Do you know of any content examples or new online demos that we could be looking forward to?
So unfortunately, I don't know of anything that's in the plan right now, although myself and the other network programmers here would very much like to have one of those. It's just a matter of finding the time to do that among all of our other priorities. But no, we definitely see the need for that. We do use I'm not going to get into beacons too much here, but we do use beacons, for example, like in most of our internal projects. But we don't have a good example that shows how they're used. So that might come in the form of a new example. It might come as an update to Shooter Game, perhaps. But we'll see. It's something we'd like to do. We just have to find the time for it.
All right. How the heck does Paragon get away with replicating so many minions when only a handful of characters or vehicles usually grind my game to a halt?
That is an excellent question.
Optimization, yay.
Yes. So I noticed this. I saw this question on the forum, and I forgot who. Somebody replied, mentioned Oodle, which is a compression library from Rad Game Tools, which we do use in Paragon. But that is really only. It helps us reduce the bandwidth that we send across the wire a bit, but it doesn't really directly help the case where the server has to, simulate all these minions that are walking around, right? So there are a couple of different techniques that we use in Paragon for that. One is you can set the net update frequency and the net call distance are kind of two of those replication variables. Maybe I can find those in the editor here. We'll just open this projectile here. So these are options that are going to be on all actors. So what we've done in Paragon is we've kind of customized some of these to be much more aggressive, so that the server spends less resources on them. So that the cull distance is basically just what it sounds like. If you are a client player and this actor is more than this cull distance away from you, then the server will not send you that character. So that reduces the number of characters that have to be sent to each client. And it reduces the number of characters that each client has to simulate on his own. The net update frequency is another big help here. So generally, so this is a frequency in times per second. By default, it's 100, which usually for most games, if they're 30 frames per second or 60 frames per second, this means that the server will try to update that actor every frame. And updating in this sense is the net update, which is the server comparing all of the properties of that object, all of the replicated properties of that object, to see which ones need to be updated and sent out to all the clients. And doing that can be pretty expensive, especially if you have a lot of actors with a lot of replicated properties. So one of the tricks you can do to optimize that for CPU usage on your server is to reduce the net update frequency of as many actors as you can get away with. And that'll cause the server to maybe not evaluate certain actors every frame. It kind of spreads the actors over more frames and reduces the load on the server. The trade-off here is if your update frequency goes below your frame rate, you might miss some updates, so you might see some artifacts. Most of those will get smoothed out, but it's just something to be aware of. If you have custom movement code or something, you'll want to definitely be aware of that and make sure you're smoothing between positions if you're getting them less frequently. So those are two big ones. Just real quick, a couple other things. We do have a custom character movement component for the minions in Paragon. And again, I'm not like a big expert on that, but at a very high level, we use a custom movement component, and we very aggressively, almost like culling, we very aggressively throttle how often we tick the movement components for minions on the server as well, to further reduce the load on the server. So by default, the component will just tick every frame that the server runs. But movement components can be one of the most expensive things to tick. So doing that saves a lot of CPU time as well for the servers.
Yeah, we should probably have someone come on and just do a live stream specific to talking about character movement component, because it does kind of unlock a wide variety of mechanics for you. Let's see.
Yes, definitely.
Let's see. Someone had said that they would love to hear more about the replay system and how it was implemented in Paragon specifically. But yeah, can you talk a bit about how replay works?
Yeah, I'd be happy to. So I was actually one of the programmers who did a lot of work on the replay system for the engine and for Paragon. So I'm pretty familiar with it. We basically, Paragon just uses the replay system that's built into the engine that you can see it in Shooter Game or your own projects. So it's built on top of that. It uses all the same core technology. We have the dedicated servers record replays. So basically every server that's running a game records the replay of that game and sends it to one of our own web services that's basically just a database that stores the replays. And that's how you get access to the replays of pretty much any game that's been played in Paragon. We also, on top of the engine system, we kind of have our own, the Paragon specific stuff. We have like our own player controller for the replay spectator. We have our own spectator pawn for, that we used for the different camera modes. We implemented, the camera modes that you see in the replay system. So I mean that's kind of a high level. You could again deep dive on any of those things and probably have a whole nother stream on each of those if you wanted to.
Oh yeah. I think that one's come up a bit, and we've talked about it in previous streams with Paragon's people here, but not in too much depth yet. But I think that kind of gives them an idea. Let's see here. Let's see. A lot of these. We've got quite a few requests here, guys. Sorry, I'm just kind of parsing through the things that are requests versus what's a question for us to answer here. We are not going to be covering gameplay abilities. Sorry, guys. Let's see. I'd love for them to talk about the progress made with the character movement component. Again, more character movement component questions. Jeez. Let's see. We did have a few come in more recently. I'll see if I can't grab some of those a little bit. Let's see. How would you handle movement correction and prediction in a high latency situation?
Well, the easy answer is to use our built-in character movement component,
Yeah.
which should generally handle that stuff. It kind of depends on your specific case. Generally, you'll still want to, smooth out position updates, right? So when you get a position update, you're not going to want to snap the character directly to that position as soon as you get it. You'll probably want to, store that position and then start interpolating towards it, which can help smooth out jumps that you would see from latency.
All right. Are there any things to keep in mind about replication in terms of making a VR multiplayer game? And actually, we have a lot of questions in here just about is it possible to test multiplayer VR locally, and how would you design multiplayer VR? I know that we've got a lot of VR stuff going around Robo Recall, but it's all single player.
Right.
Yeah.
So I am not testing multiplayer VR locally is a little bit tricky, although you should be able to run like an instance on the headset. Like I think you can only have one VR headset, connected to a local machine, as far as I'm aware. But you should be able to, run one instance in the headset and then start another instance on the same computer, and then have those two, connect to each other. Assuming one is the server, or you can run a dedicated server on your machine as well. In terms of, there was the one question about what things to keep in mind when developing multiplayer for VR.
Yeah, that was right up there.
I have a couple quick thoughts on that. That's going to be highly dependent on your specific game and what's important, what your multiplayer gameplay is like, and what's most important for the players to see at low latency, for example. I would say in general, you're probably always going to want to predict the movement of your local players, hands and headset, because VR has such strict latency requirements. You're absolutely not going to want to wait for a round trip to the server and back before you see your locally controlled objects in VR move. Aside from that, it really depends on your game and what exactly you're trying to do. I would say a lot of the guidelines for multiplayer games in general apply to VR as well.
Yeah, I just assume that it requires a little bit more in the way of replication. I know that Servios has Raw Data, which is a multiplayer VR game on UE4. You can probably take a look at that for examples, and I think they talk a little bit about their games development in a few different blog posts.
I guess another thing I'll just point out that I think I had mentioned earlier, or I thought of earlier, is since VR generally will be running at a higher frame rate, right? 90 frames per second, is the standard generally. Depending on how your replication is set up, that might actually lead to your game using more bandwidth than you would otherwise if you were running at, say 60 frames per second. Like if you are, for example, like I mentioned the net update frequency earlier, if you have a high net update frequency, and you have, like, say, a listen server running in VR at 90 frames per second, that might start eating into your performance as the server tries to process all of those actors every frame. So you might want to take a closer look at your net update frequencies and potentially the bandwidth you're using, because if you're sending, a replicated event or an RPC every frame and you're running at a higher frame rate, that will end up using more bandwidth because you're sending more data per second.
I think that also kind of helps dive into a question that was just posted by Dupa. What is the advantage of RPC versus message passing interface? I think that at least gets us into that question.
So RPC is, it stands for Remote Procedure Call. It's the term we use to refer to the kind of the built-in function replication system that we have in UE4. So if you create a replicated event in Blueprints, for example, or if you mark a U function as replicated in C++, we refer to those as RPCs. And the advantage of those is that they work with all the other replication systems in UE4. So you can put them on your U objects that are, your actors that are marked as replicated, and they will kind of just automatically work. You can mark it as replicated and then call the function, and it will replicate, as you would expect, pretty much. I'm not sure exactly what the message passing interface that's being referred to is. We have the like messaging system in UE4 that we use to like communicate between instances on the Unreal front end and such, which is kind of a separate system. Like that's not really designed for sending data between actors in Unreal game instances.
All right.
So if you need replication in your game code, generally stick to RPCs, I guess would be my advice there.
All right. We have a lot of questions and only so much time before Clint has to go to a meeting, so I just want to make sure that we get a few more of these in that have been popping up a lot.
Sure.
And okay, this question by Zenthorx, we have a few questions previously, but I feel like Zenthorx's question will really help a lot of people. What are current Blueprint limitations for a multiplayer shooter game, for example? What are a lot of people have been asking? What are some Blueprint limitations versus when they're going to have to like start stepping into C++ for replication?
Okay. So most of the basics you can implement in Blueprints. I mean, the example I was showing earlier is just the first-person template completely in Blueprints, and it was a very simple, replicated shooter game. Basically, of course, it doesn't have a lot of, it doesn't have player health and scoring and all that stuff. Those things would be pretty straightforward to implement in Blueprints. Where you're going to start running into limitations is where you want to get into more advanced features, and when you start optimizing, probably optimizing your game. Like I mentioned, some of the optimization options in Blueprints, there are some that are only available in C++. Like I don't believe there's a way to override the relevancy functionality in Blueprints. So relevancy is a whole nother topic that we could dive into. Essentially, there's a virtual function on all actors. I believe it's called isNetRelevant4, which you can override to customize the relevancy behavior, which is another way to kind of optimize your server by having custom logic to say whether certain actors are relevant to certain clients. And if an actor is not relevant to a certain client, then the server won't send it to that client, which saves bandwidth, saves CPU cost on the server and client, because there are less actors for the client to run on his side. I guess there are some limitations so I mentioned the online subsystems earlier. We have some Blueprint nodes that interact with those, but not all of the functionality in the online subsystems is exposed to Blueprints right now. I know that's been requested before, and we hope to get to that at some point. So if you wanted to, set custom matchmaking data on your sessions, for example, I don't believe that's exposed by the engine Blueprint layer right now.
Yeah, I think there's still quite a few functions. They're not totally exposed. Michael Auer points out uLocal message is still not exposed, but these are things that we can expose over time too, as you guys keep giving us your feedback and feature requests. So that's good to have. All right, and I guess in the same vein of Blueprint versus C++, Manuel Arnold asks, is there any performance difference when using replication in BP versus C++?
There's no extra inherent overhead in BPs. Everything will end up using the same system under the hood. So if you create a replicated event in Blueprints, once that blueprint is compiled and once it's actually running in the engine, it uses the same machinery that a C++ replicated function would under the hood to get all of the data actually across the wire. So nothing beyond just the normal overhead that you would have, from the Blueprint virtual machine in a single player game.
All right. Let's see. Olento asks, I want to send network updates. Oh wait, this is a different one than I thought it was. Oh no, here we go. Sorry, started reading one and started reading another. All True is asking, UE4 network architecture as client server, but can we still have two dedicated servers communicate using UE4 objects with beacons or something?
That would be kind of tricky to do out of the box just because of the client server architecture, right? Like most of the network architecture does expect there to be one server. However, you would probably have to customize the engine a little bit, and you could use a system similar to beacons. So this will getting into a little bit of the details here. There is the NetDriver object, the UNetDriver object in the engine is kind of what manages most of the low-level networking stuff. And basically, an instance of a NetDriver is either a server or a client. Nothing would prevent you from instantiating another NetDriver on a server that communicates with another server. And beacons are essentially, they use an extra NetDriver beyond the default one that is on the U world. Mm-hmm. So this might only make sense to like maybe programmers who have dug into this stuff a little bit.
Luckily, they're watching.
So yes, it should be possible by creating your own. You would kind of have to spawn your own and manage your own NetDriver, but that should be possible.
All right. So let's see here. Olento is asking, are replication data packets sent directly from game thread, and if so, at what stage of the game loop does that happen? There you go, right there.
There it is. Okay.
Yeah, he's got a couple of questions about how replication data is being sent for packets here.
Okay, sure. So yes, data packets are sent from the game thread. I believe it's there's again going back to the NetDriver object, which kind of handles all this stuff. Mm-hmm. I believe the function is called tick flush on the NetDriver, which does get called in the main tick loop. I forget exactly where. We could pull up. Is this Visual Studio?
Yeah, I got Visual Studio open right there. Yeah.
Does this have?
You can bring it over to the right screen. Otherwise, they won't be able to see it.
Right.
There we go. What you looking for?
Solution Explorer.
Yeah, I think it's under Window. No?
Solution Explorer.
Oh, weird.
There it is.
Most other things it's Window.
Do you know if this has Visual Assist?
Oh boy, I think this one does not have Visual Assist. I think this is just like straight up Visual Studio, because there's been a few times that I've looked through the YouTube comments and they're like, are you guys not using Visual Assist? No, I don't totally know if we are or not, because sometimes it is actually there where someone will get on here and install it, and then we do system refreshes on this machine.
Sure. Mm-hmm. Okay, so here it is. So this is your NetDriver tick flush, like I mentioned. This is where it all happens. The server will call this server replicate actors function, which does all the heavy lifting of, going through all the replicated actors and comparing their properties and sending them out. And this, we can actually probably see where this is called from. I think it's called from the world tick at some point. Let's see if I can just find that real quick. Level tick. Yeah, here we go. So this is in level tick, uworld tick. The file is leveltick.cpp. But this is just in the main actor tick loop. After most of the tick groups have run and everything. So that's where it is. You can dig it, take a look at this code and kind of trace it through and see what's going on there.
All right, cool. I hope that gets you in the right direction. Let's see. Next question here. Raildex asks, what's the difference between variable replication replicated and rep notify? Rep notify lets you implement custom behavior, but what for when a variable gets updated or sent? Question mark.
Yes. So rep notify will also replicate the variable, but it also lets you. It'll create an event for you, assuming you're doing this in Blueprints. You can also use this in C++, of course. If you use it in Blueprints, it'll create an onRep event for you that will get executed on the client whenever that client receives a new value for that replicated property from the server. So if you want to, you have some value that changes and you want to play, a particle effect when something in the game happens or something like that. A very simple example, but that's what rep notifies are for.
Sweet. That's cool. What's the difference between using a branch instead of switch has authority? Because you had the has authority node and then you went into a branch, but I think that there's like a full is valid check-esque node.
Oh, I think you're probably referring to the I think there's a switch has authority macro built in.
Yeah, there you go.
Yeah, so this is just a macro that kind of makes this more convenient. If I can just jump.
I think you can double click it even.
Oh yeah, probably.
Yeah.
Oh wow. So this is exactly what I did. I just my excuse is that I spend most of my time in C++. So
you're not wrong. That's actually a very good thing to use there. I think it was Per Stenback had said that. Thank you, Mr. Stenback. Let's see here. How do you replicate something only for specific players? For example, I want an invisible character only to replicate to his team, but not the enemy team. Oh.
So that's a good question. We do have replication conditions. I believe those are in this build. I would need to add a replicated property. So we have some built-in replication conditions, which probably wouldn't work for a team-based game. But we have some conditions like owner only or skip owner, which would work for things like the owner is going to be the local player who's controlling your local character. So there are a lot of things that might only be relevant to that character. Like for this first-person example, you saw the local player was the only one who saw their weapon and hands. Right, so if there were some variables that only were relevant to those meshes, for example, you could use some of the built-in conditions for that. And if you dive into C++, you can actually override and use custom replication conditions, which might be the best option if you wanted to do like what you were saying for a team game. You could also use the relevancy system. Or something similar, where the server would have the logic to determine, which actors are visible to who or which team, and then based on that, you could use, override is net relevant for on your actor, and return false if that character was invisible, and it would stop replicating to that client entirely.
Awesome. See, we've got a few very specific questions, and then a few people are asking about what the best resources for learning about building multiplayer games for Unreal Engine are. So there is Shooter Game, but we have a couple other games that do have multiplayer, and we do have a VR game that has multiplayer, as a matter of fact, now that I'm thinking about it, because I forgot Couch Nights is totally multiplayer and VR, and it's just built for the DK2 initially. And I'm sure that there's a few more that I'm just totally not remembering off the top of my head, but we also have a couple other games that are in our mod editor that are also online, and I'm sure that they have a little bit you can explore in there. But yeah, Shooter Game is probably going to be your best resource for a C++ project that's available online, unless you know of anything.
Yeah, Shooter Game was my first thought. My first thought as well.
I know that, and it was already posted once in chat. I'll have to try to remember to get this into the archive details. But Cedric or Exy also put out a really great breakdown and tutorial of how to do C++ and Blueprint. networking. But yeah, I think that's probably our best one that's like official is the shooter game. And then if you're interested in doing VR stuff, also check out Couch Nights, which is available on the Learn tab. And we should definitely probably talk about physics replication, things like that.
Yes, that's come up a lot.
Yeah, it came up quite a bit. So is there anything you want to discuss on that?
So physics is kind of a tricky issue. So, I mean, as you saw in this example, you can do kind of simple physics. There was just a static mesh that had physics simulated on the server, and that replicated down to clients. So, I mean, in that sense, it works. I know a lot of people were kind of asking about client prediction and all that. So the caveat here is I'm not really a physics expert, so I'm not too familiar with all that stuff. What I can say is that we have talked about it internally, like support in the engine. Again, it's a a priority thing. It's pretty tricky. I can't promise anything. We may or may not look at it more in the future.
Cool.
It's also, there are likely to be a lot of cases that are kind of game specific, depending on how your physics objects are moving, whether you're using vehicles or not. And I saw I saw the forum thread where some people were kind of working on getting this working on their own, which I think is great. And I followed the thread a little bit, but like I said, I'm not really a physics expert here. I would encourage you to keep experimenting with it if you need it for your game. If you can get away with faking things, that is always a good option. Of course, if you can just use a static mesh that's pre-baked or whatever, always try to consider that. One of the issues with kind of predicting and then re-simulating on a client, it can be very performance intensive because you kind of have to re-simulate the physics scene in rapid succession to catch up to where the server is. So you can kind of run into performance issues there potentially. One option that might be worth exploring is to, instead of doing like a fixed simulate like that, maybe there would be a way to kind of have your locally predicted objects on the client interpolate towards the last known position from the server. You would have to kind of do some extrapolation as well. But if you're kind of just always just interpolating towards the server's position, you don't necessarily have to run all the expensive physics simulation that does all the expensive collision checks and everything.
It's just kind of shadowing it.
Yeah, exactly. And I think you could probably still get some pretty accurate results that way for potentially much better performance.
All right. So let's see. We have a couple of questions about spawning things in and things appearing. So I'm going to try to see if we can't put all this info into something big here. Sometimes it's better. Awesome Aller was asking. Sometimes it's better to always replicate rather than to replicate by distance because the initial spike of receiving all of an actor's data outweighs the updates over time. Do you have any suggestions to guidelines about this? And then we had a couple other questions about how would you handle, like a sudden spike of lag, or not necessarily like lag as it is actually, but like a sudden spike from spawning in a lot of characters. And then another one here is about, let's see here, level streaming and how to handle level streaming. But I think these all kind of come down to the same. I want to bring a large amount of information in, or do I not? How do you handle that?
Right. So let me just catch up on these questions. So guidelines about
that one there.
Always replicating versus replicating by distance. I mean, if you always replicate, you're still going to have a spike. Like, I would think your spike would just be bigger if you're replicating everything, because you're replicating everything in the world instead of everything within a certain distance, right? So, I mean, unless I'm misunderstanding the question, it seems like you would still just get a large, or even potentially an even larger spike. I guess you could have a case where, like, you have a bunch of actors in one location and they all suddenly come within the distance threshold at one time, and then you'll get a spike there as well. And it'll also depend on how often the properties on your actors are changing, because we do only send the properties that have changed.
Mm-hmm.
So if things aren't changing very frequently, then it's not as big a deal to replicate them all the time. If you have a lot of changing properties and you try to replicate them every frame, then you would potentially run into CPU performance issues there on your server.
All right.
So yeah, a lot of it will come down to your game and how many things you are replicating.
Yeah. In this instance, Aller came back to say he wants to know about always replicating an actor, not just like the entire world, because he's seen this spike a lot with pawns in particular. I don't know if you've seen that as well.
I mean, again, it'll just depend. Like your game may have more pawns than, you may have an excess of pawns as your actor types.
Mm-hmm.
For example.
And then there's the question of like how complex your pawn-derived classes are that you've made. Let's see here.
Right.
All right. Middle asks, how often are values updated server to client? Did we answer that one already?
Sort of. I think I kind of touched on it.
Yeah, you got pretty close.
It's I mean, there's not really a straightforward answer here. Basically, so the server will continuously be comparing the current state of the replicated properties on actors to the last known state that it knows that the clients have received. So that way it will only send values that have changed. So the only bandwidth cost is for values that have changed, but the server will still use CPU time to compare those properties with the old values to know whether it does have to send them or not.
All right. Now we're getting pretty close on time, so this is going to be the last question for the show. Fresh Lemonade asks, can you show, or is there a way to simulate latency and packet loss?
That is an excellent question, and yes, there is. I can actually show you in this demo, I believe. So let's just go back to a simple two-player case here, and then there are a couple of console commands that you can use, and you can find these in code to see like all the different options. But if you do, so there's net packet lag is one. Packet is abbreviated PKT, and so this is a number of milliseconds, I believe.
Yep.
So if I just add 200 milliseconds of lag, you will probably see, for example, like the client's projectile is not popping out as quickly as it was before. We could make this even more extreme for illustration.
Let's go into give my Counter-Strike days of playing as the guy with 1,000, paying just to be that guy.
Right. So
the pain.
So you can simulate lag with that command. And what was the packet loss?
Yeah, packet loss. Yeah.
Yeah, so packet loss is the other one, and this is a percentage of packet loss. So there'll just be, this % chance that any one particular packet will get dropped. It might be hard to see the effects of this, but I mean, you can see this. I think I still have the lag set up. But essentially it'll look more laggy because as we drop packets, we'll have to resend more packets, which will take longer, to get the updates across.
All right. So yeah, that at least should help you guys out with testing that. It is built directly into the console commands. I see that we do have quite a few other questions here, so I'm going to give those over to you to hopefully we can get some details out on the forums on these last few. But I'd just like to say thank you so much, Ryan, for coming on. We got to learn a lot about replication and multiplayer, and how multiplayer works in UE4, and also just like a lot of good advice on building multiplayer. I'd like to say thank you all for coming out. It's really awesome that you all came out here. It seems like our numbers are pretty high today, so that's awesome. And yes, thank you for asking all those questions. Please feel free to come over to forums.unrealengine.com, go to the event section to post anything else you might have not gotten a chance to throw at us here. And also make sure to come in on Thursday of this week at 2 p.m. 2 p.m. Eastern time to come see a nice stream where we're going to have Lauren Ridge, Mike Fricker, and Yannick are going to come back on to talk about the VR editor and the updates that came to that we got to see over at GDC when they got to do a little bit during the keynote. So we'll get to expand on that more and talk about what they've been working on. So anyway, hit like, follow, subscribe, all the upvote buttons and whatnot, whatever version of social media and video streaming you are watching us on. Thank you so much again for watching, and we'll see you all next time. So goodbye.